Suspended at a height of 200 meters, the massive concrete towers regularly sway from severe hurricane winds, creating a glaring physical paradox. Why does the water never spill over the infinity edge? The answer lies hidden beneath the surface of this suspended structure, where a continuous mechanical battle unfolds. The infinity pool requires an absolutely perfect horizontal plane to function, but aerodynamic testing reveals that violent storms and slow ground settlement constantly shift the foundation. At the very edge of the basin, the water stands perfectly still like a sheet of solid glass, even as the building physically tilts. Beneath the heavy liquid mass, steel structural supports continuously resonate with deep, invisible micro-vibrations. The system demands absolute precision. To counteract this relentless shifting, engineers integrated a network of over 500 hydraulic jacks directly beneath the pool frame. These mechanical columns execute continuous elevation adjustments to actively fight the structural sway. Simultaneously, a tuned mass damper weighing 5 tons absorbs the incoming kinetic energy. This massive steel component, roughly the size of a commercial delivery truck, actively neutralizes the subtle tremors before they can ripple through the water. A concealed piping network quietly circulates millions of liters of water to sustain the visual illusion of a boundless horizon. This vast aquatic system operates as a living, constantly adjusting machine rather than a static architectural tub. The structural risk remains constant. Ultimately, all this circulating mass of water rests entirely on a highly unstable deck suspended over a sheer vertical drop. These 500 jacks save the water, but the deck itself on which they stand literally hangs over an abyss at Tower 3. The northern observation deck projects outward by 67 meters into open space. 67 meters of empty air. That equals the height of a 20-story building jutting horizontally over the city skyline. 0 supporting columns beneath it. 200 meters of sheer vertical drop. Without intervention, the sheer mass of this canopy creates a fatal twisting force. The steel desperately wants to snap. Crews spent months continuously hoisting these sections into the sky, merging them into a solid platform the length of an aircraft carrier. But simply lifting the metal was only half the battle. Keeping it from overturning and plunging into central Singapore requires a brutal mechanical trick. Engineers transformed the entire cantilever into a colossal seesaw. Counterweight spans drive incredibly deep back into the building framework. Hundreds of tons of hidden steel constantly pull backward inside the concrete core, aggressively balancing the enormous canopy suspended out in the void. Assembling the suspended canopy overhead is impossible. 10,000 tons of steel. They drag it up intact. The scale equals an aircraft carrier. They lift it 200 meters straight up. One segment spans 80 meters. It weighs 1,400 tons. Standard cranes snap under this. Engineers deploy strand jacking systems. Hydraulic cylinders grip heavy cables. Each bundle packs 50 strands. The steel cables groan. Metal grinds. They pull the heavy bridge, millimeters at a time. The massive structure crawls upward, 10 meters per hour. Rough mass meets surgical precision. Red laser beams cut air. They track every structural shift. GPS monitors real-time movement. High winds hammer the steel. Twisting means total collapse. Tension builds. 0 mistakes allowed. Precision rules. At this dizzying bird's-eye height, the absolute margin for catastrophic error shrinks down to just a few unforgiving millimeters. But before hoisting that steel aircraft carrier into the sky, engineers had to build concrete supports that constantly threatened to collapse until their junction at the 23rd floor. Pouring cast-in-place concrete in cramped central Singapore triggered a relentless battle against gravity. The towers lean at a severe 26-degree angle. With every new poured floor, the immense dead load of the structure generated violent lateral forces. The building actively tried to tear itself out of the foundation. The towers wanted to fall. To prevent a catastrophic failure, construction crews rigged the precarious concrete shells with temporary bracing and heavy pre-stressing cables. Deep inside the unfinished walls, thick steel tendons hummed under a pulling force equivalent to the weight of several fully loaded freight trains. These hidden artificial muscles absorbed the deadly offset loads. They kept the leaning concrete upright, a fragile high-wire act. These temporary lifelines had to contain the tearing forces long enough for the two leaning wings to finally converge. Everything hinged on the massive link beams waiting at the 23rd floor, the only structural solution allowing the builders to safely reach the final height of nearly 200 meters. The unbalanced concrete skeleton groaned under the immense gravitational pull. A precarious stillness hangs in the air just a second before the heavy steel joints permanently lock the leaning bodies together. This crazy tower tilt is no builder's whim. It is a fatal design. A literal deck of cards. It broke engineers' brains. Forget Vegas, forget Macau. How do you cheat gravity? Normal skyscrapers push weight down. These towers lean outward. Load shifts, walls bulge. Invisible pressure tears the concrete. Steel rebar stretches. Concrete screams. The structure wants to snap. Watch the roof. The sky park sits high. 340 meters long. Tens of thousands of tons. A massive steel leviathan. It crushes the sliding cards. 2010 changed everything. The complex finally opened. Gravity pulls the roof down. The facades buckle. Bending forces multiply. Instead of traveling straight down, these colossal eccentric moments bypass traditional vertical supports and discharge their massive horizontal tearing forces directly into the earth below. And these colossal bending moments slammed into Singapore's weakest point, soft sludge instead of solid earth. The ground was a nightmare. Instead of reliable bedrock, engineers faced saturated, reclaimed marine clay. Thick, squelching mud collided with the relentless pressure of subterranean groundwater. Water wanted the land back. To anchor the leaning towers, crews needed deep structural roots. Massive concrete columns plunged straight down. Each shaft measured 1 to 2 meters across, roughly the width of a passenger car. Over 5,000 individual piles. This sheer volume of concrete transformed the weak bog into an impenetrable subterranean fortress. Heavy augers tore through tens of meters of unstable wet clay. Steel teeth ripped through the dark slurry, aggressively chewing downward until they finally struck solid rock. Those 5,000 steel piles anchored in the dark mud became the exact foundation for what experts openly called an unrealistic illusion. Singapore decided to build colossal skyscrapers on reclaimed territory behaving like a wet sponge. The initial architectural drafts displayed 3 asymmetrical structures, rising more than 200 meters into the sky. They leaned menacingly toward each other like gigantic falling dominoes. Critics quickly dismissed the radical blueprints as a beautiful but physically impossible fantasy. To execute this extreme structural anomaly, the city-state bet an unprecedented $5 billion directly against the laws of gravity. This arrogant financial gamble demanded that engineering mechanics yield to immense capital. Designers calculated the massive bending stresses of concrete towers tilting at a severe 26-degree angle. Every steel reinforcement worked strictly to counteract the sheer gravitational pull threatening to snap the inclined columns. Engineers meticulously hoisted a massive platform, longer than the entire height of the Eiffel Tower, up to an elevation of 55 floors. This heavy cantilevered roof seamlessly locked the 3 leaning pillars together over the urban abyss. Immense wealth violently subdued fundamental physics. The impossible silhouette now hangs completely motionless above the bay. But those $5 billion went to more than just fighting gravity. Beneath the surface of the towers, engineers hid an entire mechanical city covering 845,000 square meters. That is the exact footprint of a self-sustaining metropolis. 150 football fields compressed into a single breathing organism. Slice through the pristine architecture and the illusion of calm instantly shatters. Deep below the lobby marble, the foundation constantly vibrates with a low-frequency hum. Heavy transit trains rumble directly through the integrated underground station. Right above the tracks, massive pumps push thousands of gallons of chilled water through industrial steel veins. The scent of machine oil and ozone fills the technical corridors. Behind the silent walls of 2,500 hotel rooms, a chaotic nervous system operates flawlessly. 4,000 kilometers of electrical cabling pulse with high voltage power. Enough copper wire to stretch all the way to Tokyo. Above ground, this heavy mechanical beast connects to a delicate exterior. The lotus-shaped art science museum anchors the base. No heavy concrete here, just pure geometric precision. Assembly crews craned and fused 5,600 prefabricated steel components to build the curved pedals. Welders worked blindly in the dense tropical heat. Every single structural joint demanded absolute millimeter accuracy. Global markets collapsed. Budgets burned. The machine never stopped. Fusing luxury theaters, a massive casino, and active railway lines into one site required brutal synchronization of spatial and electrical engineering. This monumental labyrinth of life support systems, commanding a final price tag of $5.5 billion, was completely assembled and activated in exactly 3 years. A decade later, with the system running flawlessly, Singapore decided to complicate everything again and invest $8 billion into a fourth tower. This 55-story structure immediately discards the safe vertical geometry of its predecessors to embrace a twisted form that actively fights against gravity. At the base, a sweeping column-free roof spans a colossal entertainment arena capable of seating 15,000 spectators. Erecting this heavy structural canopy while supporting a massive leaning tower above required unprecedented load distribution methods. The sheer mechanical complexity of stabilizing this unusual silhouette drove the initial budget from $3.3 billion to an astronomical $8 billion. That single financial figure roughly equals the total construction cost of 2 modern nuclear power reactors. The core structural nightmare stems directly from the dramatic posture of the new high-rise. The steel and concrete framework aggressively curves and leans forward at an extreme angle of 45 degrees. A conventional skyscraper drives its massive weight straight down through uniform columns directly into the foundation. This tilted design instead pulls the heavy upper floors outward, generating immense shearing forces along the primary support beams. The physics are merciless. To complicate the structural mathematics further, a massive cantilevered sky park extends boldly past the very edge of the roofline. This radical asymmetry permanently shifts the physical center of gravity outward, pushing the building's load directly into a highly critical zone. This 45-degree bend is another dangerous bet in Singapore's engineering casino. They started in mud, soft marine clay, a highly unstable foundation. Enter the fourth tower. It defies logic. It challenges basic physics. Stakes are massive, $8 billion. That equals the cost of 2 nuclear submarines. Ambition battles raw gravity. Physics hates extreme asymmetry. The original trio stands perfectly balanced. This new structure breaks that harmony. Load shifts outward. Stress vectors multiply rapidly. Pure structural arrogance. A terrifying visual illusion. The skyline holds its breath. Whether this audacity will shatter everything they built remains a question hanging in the void.